Imagine a cosmic ballet that has been unfolding for billions of years. A dance where entire star cities, galaxies, gracefully collide, merging, tearing each other apart, and giving birth to new structures in a vast and incomprehensible timeline. It's a spectacle so immense that when viewed from afar, it seems more like a myth than reality. Yet it's not a far-off dream, it's the universe's unavoidable destiny. The forces at play in galactic collisions are so powerful that they shape the very nature of the cosmos. They are more than just dramatic events in the sky. They are the engines that fuel the creation of new stars, new planetary systems, and sometimes even the formation of supermassive black holes. These cosmic collisions offer a profound glimpse into the past, present, and future of the universe itself. Among the galaxies on a collision course, one of the most fascinating and terrifying is our very own Milky Way. In billions of years, our galaxy will crash into its neighbor, the Andromeda Galaxy, in an event that will fundamentally reshape the night sky as we know it. But this collision is not unique. It is part of a much larger, inevitable process, a dance of destruction and rebirth that stretches across the universe. The concept of the cosmic calendar was first popularized by Carl Sagan, a renowned astrophysicist, to explain the vast timescales of the universe. He compressed the entire 13.8 billion year history of the universe into one calendar year, with each day representing approximately 38 million years. In this timeline, human history makes up just the last few seconds of the year. But galactic collisions, which span millions and even billions of years, often make their mark on the calendar in a way that is both awe-inspiring and humbling. At the beginning of the cosmic calendar, shortly after the Big Bang, the universe was a chaotic and violent place. Matter was slowly cooling and clumping together, forming the first stars and galaxies. During this early phase, galaxies frequently collided and merged, laying the groundwork for the formation of larger galactic structures. These collisions were essential for the formation of supermassive black holes at the centers of galaxies, which would later play a role in subsequent galactic interactions. By the time the universe had reached a few billion years of age, galaxies had settled into a more structured but still dynamic existence. Collisions continued to occur, albeit less frequently, as galaxies moved through space and encountered one another due to gravitational forces. As galaxies collided and merged, they often underwent dramatic transformations. In the early stages, many galaxies were irregular in shape, and only later did spiral galaxies, like the Milky Way, begin to emerge. The forces at play during galactic collisions can trigger new bursts of star formation, as gas clouds are compressed, leading to the birth of thousands or even millions of new stars. At the same time, the energy released in these collisions can also tear galaxies apart, distorting their structure and reshaping their future. The Milky Way itself, thought to have once been a much smaller, irregular galaxy, has grown into a massive spiral structure due to past mergers with smaller galaxies. These mergers contributed to the formation of the galactic disk, the halo of stars, and the supermassive black hole at the galaxy's center. Each galactic merger leaves an imprint on the galaxy's structure, influencing its size, shape, and star formation rate. Galactic collisions are not random events. They follow a predictable timeline driven by the laws of physics, especially gravity. The stars within galaxies are so far apart that, during a collision, they rarely directly collide with one another. Instead, the gravitational forces between the galaxies cause tidal forces that distort their shapes, create new stellar populations, and trigger intense bursts of star formation. But the timeline of these collisions is far from instantaneous. The process of two galaxies merging can take anywhere from hundreds of millions to billions of years, depending on their size, velocity, and the gravitational forces at play. The dance of these colliding galaxies is a slow, methodical process that unfolds over an incredibly long period. One of the key factors that determine the nature of a galactic collision is the relative velocities of the galaxies involved. When galaxies collide head-on, the resulting interaction can be violent, leading to the formation of elliptical galaxies. When they collide at an angle, the result is often the creation of a more chaotic and irregular structure. Perhaps the most famous upcoming galactic collision in our cosmic calendar is the merger of the Milky Way and the Andromeda galaxy. This collision, which is predicted to occur in about 4.5 billion years, will fundamentally alter both galaxies. The two galaxies are currently on a collision course, moving toward each other at a speed of approximately 250,000 miles per hour. As the Milky Way and Andromeda galaxies collide, the resulting gravitational forces will cause the stars, gas, and dust within the galaxies to interact in dramatic ways. Initially, the galaxies will pass through each other, their shapes distorted by the immense forces at play. Over time, however, the two galaxies will eventually merge into a single, larger galaxy. The result may be an elliptical galaxy with a new, highly energized center and the formation of a new supermassive black hole. Although this collision will drastically change the structure of both galaxies, it is unlikely that stars within the two galaxies will directly collide. The distances between stars are vast, so while the gas clouds will compress and trigger intense star formation, the stars themselves will largely pass by one another. However, the effects on the surrounding interstellar medium, clouds of gas and dust, could create conditions for the formation of new stellar systems. In the aftermath of the merger, the Milky Way and Andromeda will have a new look. The two supermassive black holes at the center of each galaxy will likely eventually merge, creating an even larger black hole at the center of the new galaxy. This event, called a black hole merger, would release an enormous amount of energy in the form of gravitational waves, which would ripple through space-time itself. Once the Milky Way and Andromeda have fully merged, the resulting galaxy will begin a new era of evolution. It may become a more stable elliptical galaxy with a smaller rate of star formation. Over the next several billion years, the stars in this new galaxy will age, and eventually the galaxy will evolve into a relatively quiet system, with only a few remaining stellar nurseries. However, the cosmic calendar doesn't end with the Milky Way and Andromeda merger. The universe continues to evolve, and the process of galactic mergers will continue. As galaxies collide, new stars will form, black holes will merge, and the structure of the universe will continue to change, albeit at a pace that is nearly incomprehensible to the human mind. The forces behind these galactic collisions are as magnificent as they are destructive. The most significant force in these events is gravity. Gravity pulls galaxies toward one another, causing them to accelerate as they approach. Once they collide, the gravitational forces at play become even more intense, distorting the galaxy's shapes and triggering the formation of new stars and structures. Other forces, such as the release of gas and radiation, play an important role in shaping the outcome of galactic collisions. The pressure of the gas clouds during a collision can trigger massive bursts of star formation, while the energy released during a black hole merger can have a profound impact on the surrounding galaxy. When we look up at the night sky, we often see only the present, the stars shining down on us in their peaceful state. But the universe is not static. Galaxies are in motion, and they are on a collision course that will shape the future of the cosmos. The cosmic calendar is a reminder of the immense timescales and forces that govern the universe. The galaxies that make up our universe are not static. They are part of an ever-evolving cosmic dance, one that stretches across billions of years. Whether we are looking at the past or the future, the grand collisions of galaxies are a key part of this spectacular, never-ending cycle. As we gaze into the future, we can only marvel at the fact that the most spectacular event in the universe, the collision of the Milky Way and Andromeda, may be unfolding right now. The forces behind these collisions are incomprehensible in their power and scale, yet they are the forces that continue to shape the universe, forging new stars and worlds in their wake. For those of us fortunate enough to witness this cosmic ballet, it is a humbling reminder of the vastness of time and space and our tiny but significant place within it. The story of galactic collisions is not just the story of the past, but the future. It's a story that continues to unfold on the cosmic calendar, one collision at a time. For the Milky Way and Andromeda, their inevitable collision is a reminder that nothing in the universe stays the same forever. The future of the cosmos is a dynamic, ever-evolving process, one in which galaxies are born, collide, and merge, giving rise to new forms of cosmic beauty and power. What lies ahead in this grand spectacle? Only time, in its infinite expanse, will tell.